Hello everybody, in this video we're going to talk about inverses of radical functions, and specifically the type of radical function that we're going to look at is the square root function. So it's a three-step process. The first thing we want to do is, instead of having f of x equals, let's change that to y equals. So now we should have a y variable and an x variable in our equation. And now step two, we want to switch the roles of x and y. So instead of y equals, we want x equals. And the last thing we need to do is just do inverse operations to solve the equation for y. So we're going to look at three examples in this video. And before we look about the inverse, I'm going to go ahead in this blue turquoise color, graph these three square root functions that we have. Then we'll switch over to an orange color. We'll find the inverse of each of these three, and then we'll graph those in orange to compare what's happening to the graph. All right, so for A, we have f of x equals the square root of x plus 3. So if we think about our parent function for our radical, for our square root, we would have 0, 0, 1, 1, and 1, 2, 3, 4, 2. Okay, so this plus 3 under the radical tells us to move these 3 points left 3. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, so now we can erase these 3 points, and now we can graph our radical function right there. All right, so now let's look at B. F of x equals the square root of x minus 2. So once again, if we start with our parent function, and now this minus 2 says let's move these 3 points right 2. So 1, 2, 1, 2, and 1, 2. Okay, so now let's take away these 3 original points, and now we graph our function. All right, and for the last one, square root of 2x minus 2. Now here we need to be a little bit careful because this is a horizontal shrink by a factor of 1/2. All right, now if we go ahead and plot our original parent function 1, 2, 3, 4, 1, 2. And if we go ahead and apply this horizontal shrink by a factor of 1/2, here's what that's going to do. Each of these 2 points are going to move halfway closer, halfway back to the x-axis. Okay, so instead of 1, 1, we have 1, 0.5, and instead of 4, 2, we have 2, 2. Now, since we have already performed the horizontal shrink, this minus 2 technically would be a translation right 2, but it's going to change to a translation of right 1 because we've already horizontally shrunk back towards the x-axis by 1/2, right? So you could think half of 2 would be 1, so now we just need to go right 1. So this point would be here, this point would be here, and this point would be right there. Okay, so now let's take these 3 points away without taking away our x-axis, and now we have our graph. Okay, so now let's switch over to orange, and let's go back to our first equation, and let's write down the inverse. Let's solve it, and then let's graph it. Okay, so we're going to write this as y equals square root of x plus 3, and we're going to switch the roles of x and y. So when we get to this point, we're going to square both sides to get rid of the radical. So we get x squared equals y plus 3, and now we can subtract 3 to get our final equation. So this would be y equals x squared minus 3. And once we go to graph this, we know this is a quadratic, so it's going to be a parabola. It's going to look like a U. However, our original square root function, the range was only values greater than or equal to 0. So that means our domain here is going to be only values greater than or equal to 0, which means it's only the right side of our x-axis, or the right side of our parabola. All right, so x squared minus 3, if we look at our parent function for our quadratic, so that'd be 0, 0, 1, 1, and 2, 1, 2, 3, 4. This minus 3 here tells us to move those 3 points 3 units down. Okay, so 1, 2, 3, 1, 2, 3, and 1, 2, 3. So let's take these 3 points away, and now we have our graph. Okay, so since these are inverses of each other, they should be symmetrical about the line y equals x. And that's this pink dashed line that I'm drawing in right here, y equals x. Okay, so we see that they are, and that's how we graph the inverse for A. Now for B, we're going to write y equals the square root of x minus 2, switch the roles of x and y, and let's go ahead and square both sides at this point. So we get x squared is equal to y minus 2, and we can add 2 to get our final equation of y equals x squared plus 2. And once again, we have to restrict our domain because our range was restricted on our original square root function. All right, so once again, if we plot our parent function, for our quadratic. We only want the right side because we're restricting our domain to only positive x values. We want to now apply this transformation, which is +2, which means we're going to go up 2. So 1, 2, 1, 2, and 1, 2. So let's take away these 3 original points here. All right, and now let's draw our graph. All right, perfect. So now let's add in our axis or our line of symmetry here. So once again, that's this pink dashed line, which is the equation of y equals x, which means if we folded this graph over that dashed line, then the orange function and the blue function would map on top of each other, which is what we see. All right, now for the last one, we're going to write this as y equals the square root of 2x minus 2. We're going to switch the roles of x and y, and we're going to square both sides. So this gives us x squared equals 2y minus 2. So now let's add 2 to get x squared plus 2 equals 2y. And now we can divide both sides by 2. So now this is going to give us y equals 1/2 x squared plus 1. And once again, we have to restrict our domain to being only positive x values. So if we start with our parent function, quadratic, 1, 2, 3, 4, we're going to do 2 things to these points. First thing we're going to do is vertically shrink by a factor of 1/2, which means these points are going to come halfway closer back down to the x-axis. So this point's going to be right here at 1/2. This point was at 4. Now it's going to be at 2. Okay, so we'll take these 2 points away. Now this +1 just means shift all 3 of these points up 1 unit. So our vertex moves up here, this point moves here, and this point moves right here. All right, so now let's erase these points. Perfect. And now let's graph the resulting equation. All right, now we can add in our axis of symmetry, which is y equals x. And we can see there that these 2 functions are symmetrical over this line, y equals x. So they are inverses of one another, okay? And so that's how you find the inverse of a square root function.